let's talk about basic 3D concepts. So we'll talk about the Cartesian coordinate system first. A Cartesian coordinate system is a coordinate system that specifies each point uniquely in a plane by a pair of numerical coordinates. This refers to René Descartes, who published this idea in the year 1637. Okay, so René Descartes, as you can see, is this guy over here. Okay, and I'll link you to this Wikipedia page if you want to read up on this further. So it says here the Cartesian coordinate system was named after him. And we'll look at the 2D coordinate system here first. So I drew up a basic picture for each one of these. The silly little picture to the right here. And so the 2D coordinate system has an x and y dimension and is flat. You can describe the position of a single point in 2D space using two numbers. So you can, for example, use x horizontal. You can see that red line, okay, representing x for width and y vertical for height. And the point where each of these axes intersect is called the world origin, and that will be at 0, 0. So if you have a point at 0, 0, that point is at the origin of the world, and that world origin divides each axis into a positive and negative side. And I want to demonstrate this in Houdini, but before we do that, we'll talk briefly about a transform. And basically the transform is an object's unique position, rotation and scale in the world. And transformation is something specific, like a change in the position, location, rotation or scale. And so basically you perform transformations on a transform. Okay, so I have Houdini open here, and by default you'll see that this is in the perspective view. We have these two buttons at the top. Okay, let's drop down in our scene view here, scene tab, and so I can click on that drop down, and then we have this set view. So what I want here is the front viewport, so left click on that to switch. And again we have this 3D compass in the bottom left corner of this view here, and this keeps us oriented. So currently that is y up and down, x left and right, and in this case we don't care about z because this is a 2D view. And we can also see that if you move to the left, x becomes negative, so the center of our world is at 0, 0. You'll see that we have at the bottom here you have y becomes negative as it goes down, x becomes positive as it goes to the right, and so on. So I can just go and press Alt Control and maybe left click on the box, for example. That'll add that in my scene. And I'll zoom out, and we can move objects around by simply clicking on these handles. Simply clicking on the Y handle, and this will constrain it to the Y axis, which is up and down. Left click on that to move it up. You'll see that in the parameters to the right here, this is what I talked about, the transform. So we have translate, rotate and scale. So with translate, you can see we moved it up. If I move it down, you'll see that number becomes a negative. And at 0, 0, that again is at my origin. So 0, 0, 0 will be at my origin. And again, constraining to the x-axis, in this case using this red handle, move to the left, that will become negative in x. Okay, we have x, y, z. X is the left value, y is that value in the center there, and that middle value, and then the value to the right is z, which we're not concerned with right now. If I move it to the right, this object, past, this vertical line that splits the y and x axis currently, if I move beyond that, this will become positive. So that's a basic idea of 2D. Another thing with 2D versus 3D is you don't really have any sense of depth. So this is useful if we, for example, look at blueprints for a house, right? So if you're familiar with that kind of idea, you have a blueprint of a house, maybe a top-down view, which gives you the layout of the house, and that allows you to precisely place objects and so on. And this is also very useful in 3D applications such as Houdini, game engines, and other 3D applications for object placement to keep oriented, and also if you draw out things like curves or if you want to work more precisely. we can charge scale. Maybe we want to create something that's 1 meter by 1 meter, so this cube comes in by default 1 meter by 1 meter. So you can see it takes up a space like that. So how do you get back? You can just click on this drop down again, set view, and go to perspective viewport. Left click on that, and we are now back. And so of course we also have the 3D coordinate system. Okay, just another silly example. I'm on this wikihow.com/measure bed size page. I'll link you to this. And basically, after taking measurements, right, to describe something, you can describe them in terms of width, height, and depth. So if you imagine that you're floating above and looking down on this mattress, for example, from that perspective, the top to bottom will then indicate the height. If you take the left to right measurement, that will indicate the width, and the measurement from the top side of that to the back of the mattress will then of course indicate the depth. So similarly, in terms of 3D coordinate systems, as we are discussing in this section, you can describe a position of an object in 3D space. And basically this adds another dimension. You can describe the position of a single point in 3D space with 3 numbers. You can, for example, use X for width, Y for height, and Z for depth. And once again, the point where each of these axes intersects is called the world origin, or 0, 0, 0. And this will again divide each axis into a positive and negative side. So with 3D we basically now have an extra dimension, an extra axis to work with. So as we can see, just like before, we have Y to move it up and down, X to move it left and right, and Z will now move this towards us and away from us for depth. And again, if you take a look at the transform, if you move this away from us, that will become negative in Z, in the Z value. Towards us, that will become positive. So we have these planes, so the XY plane, for example, and you can see later that we can actually move. If you hover over that small icon right there, you can actually move the object around only in X and Y, so it will only change the X and Y values. So again, it just adds basically another dimension, another axis to work with, so that you now can work in 3D. I'm just comparing 2D and 3D here. Okay, next we'll talk about Cartesian coordinate handedness. So what does that mean? Firstly, it's important to note that not all game engines or 3D programs such as Houdini are the same or use the same coordinate system. In the Unity game engine, for example, Y is up and Unreal Z is up. So if you do 3D modeling in Blender, you have a 3D model, you want to export that maybe to another 3D application, whether that be a game engine such as Unreal or something like that, then you might have to set that up properly to export in the way you would expect. If you import that into other application, it might be rotated weirdly, it might be scaled, it might be much bigger than you think or much smaller. So these are things that we have to think about. We'll discuss that in more detail eventually when we actually look at exporting things from Houdini, for example, to Unreal Engine or Unity, but this is something to realize early on. Now, thankfully, in many of these programs, you'll find that it has kind of an exporter or a helper. So Unity, for example, will basically recognize that you've exported something from Blender and it will set it up properly, whereas that's not always the case. Maya and Modo have started to add similar setups, so this makes it much easier to just export your stuff. But in many cases, you'll still have to go in and make sure you set up your scale, your grid basically, and your snapping and stuff properly. And should you then export a wall that's 1 meter high, 1 meter wide, then it shows up in the same size in the program to which you're exporting. But as I said, there are thankfully tools that allow you to do that much easier than what it was back when I first started off with this stuff. Now, in Unreal Engine 4, if you think of the world from an overhead perspective, like viewing Google Maps, for example, the location of an object on the map is defined by X and Y coordinates, and its height above the map by Z. So basically again, Z is up and down. In Unity, Y is up. So there's a bit of a difference. And so here I have an image, which I'll link you to. And we'll talk about the coordinate system handedness here. So in this image, you can see that basically these are mirror images of each other. You have left-handed coordinates on the left there, okay, and right-handed coordinates on the right. And this refers to the coordinate system handedness. And on the left hand, you can see that x, positive direction, okay, of x. So those arrows point in the positive direction. So x there is on the left thumb, y points up, and your next finger, middle finger there, points down the positive direction of the z-axis. On the right-handed coordinates, you have x pointing down towards your right thumb, and then again y along your next finger, and the finger right next to that, again middle finger right there is then pointing down the z-axis. So how can we open up something like Houdini and determine the handedness of this? Well, in most applications you have some way of determining kind of where you are and how your scene is oriented. And in Houdini, you can see in this bottom left corner here, in our scene view, in this 3D view here, you'll see that we have that little compass, and Y is up, okay, up and down. As we move over here, we can see now X is left to right, and so on. So that will help you keep oriented. And those point in the positive direction, or should point in the positive direction. So X, for example, if you move over here, we see X goes that way, you'll see it points down towards the positive direction of that X-axis. Y, positive is up, positive direction is up, and so on. And similarly, if I bring up Unity, you can see Unity has this gizmo you can click on to change your views and so forth. And so Y again is up, Z goes like that, and X is in this direction. So as I navigate, that will also navigate. Okay, so you can use these kind of gizmos to determine the handedness and well to keep you oriented in your scene. So this might kind of seem very similar right now, but what I want you to do is I want you to look at Blender to start off with. And I want you to try and firstly look at this image, okay, and then try and figure out whether Blender is left-handed or right-handed. So whether it uses left-handed coordinates or right-handed coordinates, basically. And I'll put up some irritating music and a countdown screen to indicate that we're doing an exercise, and give it a go for fun, and then you'll see how awkward it is if you have the wrong hand. And when we come back, we'll talk about this again. For this exercise, as a reference, I have Blender open here. What you want to look at is this 3D compass. Okay, so with Blender, you'll find that using the left hand, it's kind of awkward, it doesn't work quite right. And if you use the right hand, however, it does work. So Blender is right-handed. Once again, we'll look at something else here. We'll look at Unity. Again, Y is up in Unity. And so what we'll do is we'll do the same thing. As an exercise, you can try and figure out if Unity uses left-handed coordinates or right-handed coordinates. So try and figure that out. Then when we come back, we'll discuss this further. So if you try with the right hand, again things don't quite work. So Unity is left-handed, okay, left-handed coordinate system. And if you try with Houdini, you'll find it has a right-handed coordinate system. Okay, moving on. Let's talk about perspective projection and orthographic projection. So in 3D applications, we normally have various viewports such as top, bottom, right, left, front and back, and perspective viewports. These will help us place our objects precisely, and it allows us to use various tools such as curves to draw out a geometry, maybe in the left view, or maybe we add a cube, in perspective view. And so the perspective viewport has a perspective projection, meaning that lines projected along the same axis, so away into the distance, converge at a distant vanishing point. Orthographic projection, however, simulates the vanishing point being infinitely distant. So lines on the same axis are parallel, okay, and they won't converge. So let's talk about orthographic and perspective here quickly in Houdini. I'll just add a cube in my scene. As you can see, this now looks like something that the eye would mimic. This basically looks like a camera looking into this 3D world. If I go and change this from perspective to orthographic, we see perspective is checked. So if I click that to uncheck that, you'll see that this now changes to orthographic. It says ortho in that menu. And so this is what orthographic will look like. And so what I'll do is I'll copy this box object and I'll move it. And if I switch between orthographic here and perspective again, and you can press the O key, I come in here and I move this object way back. It'll look like it gets smaller as you move it way back. Way over there looks way smaller than this guy over here. Okay, so in the perspective view, if you project lines along the same axis off in the distance, they'll converge at a distant vanishing point. But if you switch to orthographic projection, this will basically simulate the vanishing point being infinitely distant. And so what would this look like? So again, I'll go in here and turn off perspective. We're now in orthographic. And I might have to rotate my view around a bit, and you'll see how to do this later. And you can see that back cube, it looks like it's the same size, and that's because that vanishing point is infinitely distant. So this basically means that depth is not represented all that clearly in orthographic projection. And this can be useful in 2D views and for object placement and so on. But if you want 3D, right, you want perspective. So turn that on again and you can see that back object is now small again. And this one is right in our face, is big, right, compared to that one back there. Okay, so this concludes this introduction to basic 3D concepts.